Hello, and welcome to this FMSP online revision session. This session is looking at the MEI Further Pure 1 specification and at the topic of curve sketching and inequalities. We'll start by looking at the specification and seeing what you need to be able to do. You need to be able to sketch a graph with information about symmetry, asymptotes, intercepts, behaviour near x equals 0 and behaviour for large x. You need to be able to find out what direction a curve approaches an asymptote from. And points 3 and 4 here are basically two alternative methods of solving an inequality. And generally one method will be obviously significantly better than the other for a particular question. So, key points to remember. First of all, find where the graph crosses the axes. Then, identify any vertical asymptotes where the denominator is 0 and therefore the function is undefined. You can identify horizontal asymptotes by thinking about what happens for very large positive and negative values of x. You can do that either algebraically or with a calculator. It's quite a good idea to do it both ways to check. And then you need to consider the behaviour of y as x approaches negative infinity, positive infinity, and each asymptote from both directions. You need to be able to justify both of these either algebraically or by showing appropriate calculations. Either method is fine. As I said, it's quite a good idea to try it by both methods so that you can be sure. You then need to mark each piece of information on the axes and complete your graph. It's a good idea at that point to make sure that you've not included any fictitious crossing points, any crossing points other than those that you identified in point 1. If you do find that you've got those, you'll need to go back and see where you went wrong. It's a really useful idea to record each step clearly so that you know that you've dealt with them and you can check each step individually easily. When you're dealing with inequalities, never multiply an inequality by an expression which is sometimes negative. It's okay if you know that the expression is always negative, you can simply reverse the inequality sign. But if your expression is sometimes negative and sometimes positive, then simply don't multiply it. There are other alternative ways of moving forward with your solution. Adding and subtracting is a good alternative. So let's look at some questions. This first one, there's no mention of a graph, so we're going to tackle it algebraically. First thing we need to do is to get 0 on one side, and we do that by subtracting, because subtracting is always safe. Now we can create a common denominator of x squared plus 4, so 5x minus x multiplied by x squared plus 4 all over x squared plus 4, and multiplying out the top 5x minus x squared minus 4x. Now then, so that's an x cubed. Simplifying the numerator, minus x cubed plus x. Now x squared plus 4 is always positive, so I can multiply through by x squared plus 4. That's always positive. Even if x is 0, it's still going to be greater than 0, so I can multiply through and simplify that. Okay, now I'm going to multiply by -1 because I like my highest highest power term to be positive. If I multiply through by -1, which is always negative, that will swap the sign. And then I can factorise. So x into x squared minus 1 and x plus 1, x minus 1. Now at this point I could draw a graph, but I'm in algebra mode rather than graph mode, so I'm going to continue by considering critical values. So my critical values are 0, -1 and 1. So working from left to right, x is less than -1, between -1 and 0, between 0 and 1, and bigger than 1. And notice I'm keeping all my inequality signs the same way so that I can see I've not made any mistakes. I'm then going to consider each of the terms in turn, and again I'm writing those in the order that corresponds with the order I've used the critical values, because that will give me a pattern in my table. So if x is less than -1, all three of those terms will be negative. Between -1 and 0, the first one will turn positive, the other two will still be negative. Beyond 0, the first two will be positive, but until I've reached 1, the last one is negative, and then beyond 1, they're all positive. Looking at the total expression, 3 negatives will be negative, 2 negatives and a positive is positive, 2 positives and a negative is negative, and 3 positives is positive. I'm looking for when my expression is bigger than 0, so I'm looking at these two, and all I have to do is read off the inequalities at the top: -1 less than x less than 0, or 1 less than x. It would be perfectly acceptable to draw a graph of x cubed minus x and identify where it's bigger than 0, a perfectly acceptable alternative, but I wanted to show this method as a way of dealing with things when you've still got expressions in the denominator, and sketching the graph is much more tedious unless you're asked to do it anyway. Let's have a look and see how the mark scheme is applied to this question. There is a method mark for an attempt towards factorising. There are 3 accuracy marks for each of the critical values implied, and I've clearly implied them up here. I haven't actually stated the critical values are -1, 0 and 1, but they are clearly implied in the working. There's then a method mark for dealing with each of the terms and seeing what the sign of my expression is, and finally accuracy marks for getting both of the correct intervals. Okay, let's have a look at a graph question. Now this question is quite nice. It leads you through it. It tells you all, at least some of the bits that you need to do. It tells you that there are 2 vertical asymptotes. It's very nice. It tells you that there's a horizontal asymptote as well, just one. You've specifically got to describe the behaviour of the curve for large positive and large negative values of x, justifying your answers. They don't specifically ask you for the behaviour at the asymptotes, but clearly you will need that in order to sketch the curve. And finally, you've got an inequality to solve, and obviously you're going to use the graph to do that, because having gone to all the trouble to draw the graph, you might as well use that just to read off your solutions. So it says write down, so they're not expecting any working, they're expecting you to be able to see it. It should be easy. So one of those 2 factors in the denominator 0, well, the 2x minus 3 is 0 when x is 3 over 2, and 2x plus 7 is 0 when x is minus 7 over 2. Now the horizontal asymptote, the numerator highest power is x, the denominator of the highest power is x squared, so this is going to tend towards 1 over x, and therefore for large x, y is going to be tending towards 0, and my horizontal asymptote is y is 0. Describe the behaviour of the curve for large positive and large negative values. So, as x tends towards positive infinity, all three terms are positive. So y is going to be tending to 0, but it will be positive, so it will be tending from above. As x tends towards minus infinity, all three terms are negative. So that's 3 negative, so y will be negative, so y tends to 0 from below. You could alternatively plug in some very large numbers and show that y is positive or negative. We also need, in order to be able to sketch our graph, as x tends towards minus 7 over 2 from below, all terms are negative, so y tends towards minus infinity. As x tends towards minus 7, 2 from above, the 2x plus 7 will have turned positive. So we've got 2 negative and 1 positive term, so y will tend to positive infinity. As x tends towards 3 over 2 from below, 2 of those factors will be negative and 1 positive, so y tends to positive infinity, and as x tends to 3 over 2 from above, we'll have 2 positive and 1 negative. The 5x minus 9 will still be negative, so y tends towards negative infinity. We will also need the crossing points, so when x is 0, y is minus 9 over minus 3 times 7, which is plus 3/7. And if y is 0, then that means the numerator must be 0, so 5x minus 9 is 0, and therefore x is 9 over 5. So now we need to transfer this information to the graph. I've already drawn in the asymptotes, and those need to be labelled 3 over 2 and minus 7 over 2. I'll put 0 in and I'll label my axes as well. Now, we found that when x was 0, y was 3/7. So we'll put that in there and label it 3/7. And we found that y was 0 when x was 9/5. So that's up here somewhere, 9/5. We then need to look at behaviour in different places. As x tends to positive infinity, y tends to 0 from above. As x tends to minus infinity, y tends to 0 from below. Draw that bit in. As x tends to minus 7 over 2 from below, y tends to negative infinity. And as it tends to minus 7 over 2 from above, y tends to positive infinity. as x tends to 3 over 2 from below, y tends to positive infinity. And as y tends to 3 over 2 from above, x tends to 3 over 2 from above, y tends to negative infinity. So those are all the pieces, and now I just need to join them up. Carefully going through that point there. You're not expected to show where maxima or minima are. Now this goes up through 9 over 5 there, and then has to come back down again to tend towards 0 from above. Now if you were to sketch that on a graphical calculator, this bump here would be on the right, would hardly show up at all. It's a good idea to take a graphical calculator into the exam, you are allowed to, and check your graphs, but do be aware that some of the key features that will appear on your sketch graph will not show up on a graphical calculator. Finally, we've got the inequality to solve. We're looking when the graph is less than or equal to 0. Well, it's negative up to minus 7 over 2. And then it's also negative between 3 over 2 and 9 over 5. Now, we've got a less than or equals to. It's always a good idea to start by writing down strict inequalities and then to examine carefully whether x can actually equal the boundaries. So if we look back at the graph, we can see that x can't be equal to minus 7 over 2. So we need a strict inequality in there. It can't be equal to 3 over 2 either, so we need a strict inequality there. But x can be equal to 9 over 5, at which point y is equal to 0. So we can put an equals in there. Let's have a look and see how the mark scheme applies to this question. So, B marks just for writing down those asymptotes. No working or justification required. There is then a B mark for making the correct observations about the behaviour of x for large positive and negative values. And there is then a method mark for some evidence of method. Here I gave an algebraic argument, but if you plugged in some large values, that would be sufficient. The other bits of information here that I've written are all needed in order to sketch the graph, but they are not specifically asked for. For the graph, there is 1 mark for the intercepts. They have to be correctly marked and labelled, so I needed to do that working. There is another mark for the left hand and central branch is correct. And another mark for the right hand branch with a clear maximum, which, as I said, you wouldn't necessarily pick up from a graphical calculator. For the inequalities, there is 1 mark for the left hand one and 2 marks for the right hand one. And for the right hand one, you would be awarded 1 mark if the only error is messing up your inclusive exclusive inequalities. Well, that's all you need to know about curve sketching and inequalities. I look forward to your company in the rest of the MEI FP1 videos and wish you all the best with your exams.